Hello everyone. So welcome to today's tutorial session. Today we will be discussing about topic modeling. So for this tutorial, we assume that you already have Jupyter Notebook installed and we will be starting with the topic modeling session. So we have started Jupyter Notebook and here we will be discussing about topic modeling. So I assume you remember what is topic modeling. So it essentially is a way to model a corpus or a set of documents where all the documents in the collection share the same set of topics, but each document exhibits those topics in different proportions. So we essentially assume that we have a corpus, and in that corpus that contains multiple documents, every document share a common set of topics. Now given those topics, they can be varying in different proportions in each of these documents. Now each word in the given document is basically drawn from one of those topics. So here we assume that every word that you see in a particular document, that comes from the distribution of a particular topic, and based on the document wise topic proportion, you get to see those words. Now to infer all this, all we have is basically the observations or the corpus itself. So to run this codes that we are discussing today, you might be requiring to install a library called Gensim. So I assume that everyone is familiar with Anaconda Navigator. So once you use Anaconda Navigator, you have to browse to environment and look for the library section here. So here just select on the all option and look for Gensim. So we have already pre-installed Gensim. So here you should ideally be not seeing the tick mark. So select this and install the library. So once the library is installed, we will import the library, and for this tutorial we will be assuming a very small corpus, which is basically a collection of 9 different sentences. So here is a tiny corpus of 9 documents, and each document essentially contains only one sentence. So in order to give this corpus to the model, we have to do some essential pre-processing. So we will be showing what all pre-processing needs to be done. So we need to convert this to a suitable bag of words format, and we will be showing how to do this. So here are some pre-processing steps that we are going to do. So for this simplistic corpus, we assume the only set of stop words are these few words, but in practicality you might have to consider other stop words as well, but there are predefined sets that you can obtain. We will show how to obtain those lists. So we make a list of all these stop words. We also make sure that all the words are converted to lowercase. So here what we do is that we take each sentence in the documents and then we split it based on the space. So we do tokenization again based on a very simple notion that if there is a space between two characters, we assume that they belong to two different words. Since our corpus is something that we are doing for representational purposes, this simplistic method will help you in doing this, but again you can rely on any standard tokenizers for this task. So text will essentially contain all those individual words. So if you see here the sentence human machine interface for lab ABC computer applications, here that document is now represented as a list of words where you can find the h in human has been turned into small h or the lowercase h, the stop word for is removed, and we essentially got a list of lists where each list shows a document with its important words. After doing this, what we find is that we find the count or the frequency of a particular word occurring in the entire corpus. For example, the word human is appearing once in document 1 and it also appears one time in document 4. So, the total occurrence is 2 for the word human. So, this particular chunk of code basically tells you how to find the frequency of the individual words in your corpus. Once that is done, we filter those words which appear more than once. So, we keep those words, only those words which appear more than once in our corpus, and we remove them. So, what you find here in the second printed statement are those words which are filtered after this particular criteria is applied. So, we can see that machine which was appearing only once in the entire corpus is removed, and similarly other words like interface, etc. So, once we have this, most often what happens is that when we have large corpora, we may not be doing it every time, like we may not be doing the pre-processing every time, because it itself might be time consuming. So, once we have this pre-processed state, we save it into any of the suitable formats. So, here Gensim provides a suitable format for saving this text called dictionary, and we save it in that format. So, if you see here in Gensim, we use the dictionary method to convert the text to a suitable internal representation, and we find that there are 12 unique tokens for the entire corpus. Once we have that, for ease of handling the data, we convert each word to a unique integer representation. So, every unique word will be given an integer ID. So, they are arbitrarily provided, there is no rationale for which number goes to which word. So, once we apply this operation dictionary dot token to ID, which is an inbuilt attribute for this model as given by Gensim, you can find that the words like minors is given an ID 11, graph is given an ID 10, and so on. Now, we assume that whatever words are that we are going to use will come from only one of these words. Now, let us take a new document which is human computer interaction. So, I have a new sentence or a new document, human computer interaction. So, I have to apply all those pre-processing that I have applied to the corpus. Since there are no stop words, I do not apply the stop words filtering explicitly, but it is also assumed to be done. Now, we convert it to something called as BOW or bag of words representation. So, a document is now going to be represented in terms of the bag of words representation, which is very similar to this one. So, we can find that you get a list with two tuples which shows 1 comma 1 and 2 comma 1. So, what essentially is represented here? So, essentially what you can find here is that we have three terms, human, computer, and interaction. But unfortunately, interaction is a word that is not available in our dictionary. So, we ignore that word when we convert this document to a vectorial representation. So, for all practical purposes, you can assume your document to be human computer, as this is what it is going to be fed to the topic model. Now, what does this first entities, that is 1 and 2, represent? They basically represent each of the word human and computer. So, if you see, the identifier for human is 2 and the identifier for computer is 1, and what you see on the right is the number of times a particular word is appearing. For example, if I add another term computer again, so it is human computer, interaction computer, the word with ID 1, which happens to be computer, has increased its frequency. So, this is basically a frequency count of each unique word that basically represents the documents. So, as we have saved the dictionary, we can also save these representations also in a serializable format, and we can store it so that we can load it later whenever we require that. So, these are all those 9 sentences that we were dealing with here. They are first converted to a list format with its relevant words. Now, we convert it to the individual usage or the individual identifier along with its frequency. It so happened that in this corpus we do not have any of the word repeating twice other than this particular word, that is the 6th word in the 3rd sentence. So, word 6 is system, and in 3rd sentence, yes, system human, system EPS. So, that is now reduced to 6, 2. So, till now we have not done anything specific to topic modeling or what we call as LDA for this particular instance. What we have done is that we have used a means to represent in a format that is much more easier to handle for the model. Now, we import the LDA model or the latent Dirichlet allocation model for the topic models. As you remember, there are different variations of topic models that are being used, as you have seen different methods in your class, like the sequential topic model and the relational topic model. Here we will be showing only the simple LDA model. So, I import this library. Now, let us assume another corpus where all the preprocessing are initially done. So, we have something like a new corpus, again a tiny corpus with few sentences, and the stop words are removed, all the preprocessing are done. We convert it to the dictionary and we convert it to the bag of words format for each of this document. So, here we get the representation. For this corpus, just to make things clear, we have created a new dictionary based on the words in this corpus. Now, comes the LDA model. So, in the LDA model, what we have to essentially provide to the system is the number of topics. So, we assume that the user or the programmer he already is aware of the number of topics that the certain collection of corpus is going to contain, and this should be provided as a parameter or as an argument to the model. Now, if you see what are the other possible options that you can use to customize this particular function, you can find what are the values. The hyperparameter alpha can be given, the hyperparameter eta or the beta as you know it, the decay and number of iterations and other convenient parameters that you can use. So, the alpha and eta are the important ones, others are for mostly for programming convenience. So, let us run this model. So, now we have added this corpus into a doc to bow representation, and we have provided that this corpus to the LDA model to get a model. This is stored in the variable named as model. Now, if we see, we can find, since we have already told the system that there will be only 2 topics, it has provided 2 topics to us, and it is showing the top terms that the topic represents. So, the topic is essentially a collection of words which is gathered from the different documents, and you can see with what probability each word is belonging to that particular topic. We can also find the same word might belong to multiple topics. Here the term bank is having a probability of 0.164, and here the term bank is having a probability of 0.196. We can find other words also repeat here, like water has 0.065 in topic 1 or the topic 2, and water has a probability of 0.142 in the first topic, which is indexed at 0. Now, if you see, ideally the probability should add up to 1. So, all the words which are represented here, when we add up the probability, it should give a probability of 1. But if we add up these values, it is not adding up to 1. So, here we have an option to show what are the number of words per topic to be shown. So, here the model has shown only top 10 words for the given topic. So, in practical scenarios we often use number of topics which are more than 10 also, like there can be 50 or 100 topics. In that case this function just shows 10 topics or some 10 topics out of the 100 or 50 topics. Now, since we have a small corpus and I am aware that the number of words is going to be less than 20, I just add the parameter number of words is equal, the argument number of words equal to 20, and we can find almost all the words that is present in the particular topic. If we increase the topic, it does not change, which means these are the only number of words in that particular topic. Now, if we want to know what is the probability of a particular word, so we get the term topics from this function. So, we can find that water has a probability of 0.128 and a 0.047 in either of the topics. Now, let us see a new document, that is bank, water bank, which was not provided to the model while it was learning the probability distributions. So, we have a new test document or a new document where we have bank, water bank, and we first convert it to the BOW representation. Once we have that, here what we find is that the word 0 and word 3. So, both the terms which are like bank and water, both the terms are more likely to belong to topic 0. So, here even if bank has a higher probability at topic 1, maybe because of its co-occurrence with water, which has a high score in topic 0, both bank and water are given a higher probability of being in topic 0 for this particular document. So, as you are aware, in topic models, given a word, it can belong to multiple topic distributions, and once you find a particular word in the document, it might be coming from any one of those topics. Now, if we see here the 5 values, which is essentially the probability of a word in that document belonging to a particular topic. So, the 5 value essentially shows what is the probability of each word belonging to each of those topics. So, if you see here the word type 3, when you add up the values here, it has a probability, it shows a score, not a probability, but a score which adds up to 2. So, if the sum of the 5 value is 2, which is and not 1, and this is indicative of the scaling by feature length. So, this always does not happen, but it is an indicative aspect here. Now, what we can see here is that we have taken the second document here, which is BOW finance. So, once we have bank, finance bank as our document, we can find that both the words bank and finance have a higher probability of belonging to topic 1. So, here if you see the word 3, which was bank, had a higher probability of belonging to topic 0, but in the second document, this is the model assumes that the word bank comes from topic 1, not topic 0. This is again assumed to be because it co-occurs with the word finance. So, we should be talking about the financial institution bank rather than the riverside or river bank. So, this becomes evident using this model. Now, let us see what are the different values that we get for each of these documents. So, we can find that the document topic. So, the first document, which is essentially bank, river, shore, water, the document representation has a higher tendency to, or has a higher proportion of topic 0 rather than topic 1. Now, individual words where all the 4 words 0, 1, 2 and 3 have a higher tendency to belong to topic 0. The 5 values, which is like the per word distribution for each word in that document, also shows the similar trend. Now, if we see next word document, which is the document river, water, flow, fast, tree, what we can find is that again it is having a higher probability of belonging to topic 0 than topic 1, and we can find that some of the words have no occurrence or no probability of occurrence in topic 1, like the 4 and 6. Now, if we look into say then one of those documents where its probability of belonging to topic 1 is 0.88, while that of belonging to topic 0 is 0.11, and we can find almost all of the words have a higher probability to belong to topic 1. It is also possible that similarly for this document we have more or less similar weights for each of the topic, like topic 0 it is 0.44 and topic 1 it is 0.55, where the confidence of this document belonging to a particular topic is not that high to be decisive enough. We can find that 2 of the words have a probability of belonging to topic 1, while the third word has a higher probability of belonging to topic 0, and we can find the comparative values of each of those words with this topic proportion. So, this is how we analyze a corpus using topic modeling or the LDA. So, Gensim essentially provides a suite of packages that helps in different topic modeling tasks, and they have a set of comprehensive tutorials. So, the tutorial that you have been seeing here has been compiled from multiple tutorials from Gensim. You can have a further look into different topics here. They, in addition to LDA, provide other topic models as well. They show topic models which include HDP, which is hierarchical display process, and they also have a model for sequential LDA. So, we can have a quick look into one of those. So, here we can find different transformations or different ways of representing a document, where TF, IDF and LSA or LSI are some of the they used to be some of the popular ways of representing a document in a vectorial representation. And we have LDA, which is what we have seen. We have HDP. So, HDP is a non-parametric version where you do not need to provide the number of topics as well. That is, it is inferred by the model itself. So, this is pretty much for the topic modeling tutorial. Thank you.